Okay, 2.6 video 2. We've only got this last example. This really should not take very long. This should be a pretty short video. Example 4. In preparation for laying new tile, Michelle measures the floor of a banquet hall and finds it to be square, measuring 100 by 100 feet. Suppose that the measurements are accurate to plus or minus 6 inches. So there might have been a little bit of an error there. We call that the tolerance. So we're going to use differentials to estimate the difference in the area, or dA, due to the tolerance. So the first thing that we need to do is we need to define the area. Well, it's a square, so that fortunately is not a hard one to do. The area is just going to be, we'll call it x squared. Okay, so now we want to find the differential of that area based upon this tolerance of plus or minus 6 inches. So if I want to find the differential, let's start off just by taking the derivative. Well, I'm going to call that dA over dx because I'm taking the derivative of the area with respect to x. So that's going to be 2x. Now, if I want to find the differential, I'm just solving for dA, which means we'll multiply the dx to both sides. So we'll get that dA, that's the differential of the area, equals 2x dx. Okay? We know that dx, or the differential of the x part, is plus or minus 6, because that's what it tells us. So we also know that the x part, which is the side of the square, is 100, because they tell it's a 100 by 100 foot squared thing. So we're going to get that the differential, or dA, is 2 times 100, because 100 is literally the side of the rectangle. That's x. And then dx is plus or minus 6. So the tolerance, or the potential error, the dA here, is going to be 2 times 100 times 6, which is going to be 200 times 6, which is going to be 1200. So it's plus or minus 1200 square feet. And that seems incredibly large to me. What did I... Oh, man. That goes to show you, you really need to read carefully. Okay, it is going to be a plus or minus here. Notice that the plus or minus is in inches, while the dimensions are in feet. So I have to change 6 inches, which is 0.5 feet. Not reading carefully enough. So 6 inches is the same thing as 0.5 feet. So it's really plus or minus 0.5. I thought that that differential seemed incredibly large, and it would have been had that been a 6-foot differential, but it's a 6-inch differential. Oops. So it's going to be 200 200 times 0.5, or half of 200, so it's going to be 100 square feet of potential tolerance. Okay, now part B, it says use the compare the result from part A to the actual difference in the actual delta A, or the actual change of area. Well, to do the actual change of area, we have to take into account both the plus and the minus of the 6 inches, or the 0.5 feet. So if I want to find the actual change of area, we'll call this delta A. Horrible, delta A. There we go. Delta A is going to be the area of x2 minus the area of x1. But the problem is we have two x2s. Again, it's really going to depend upon which way we go. So it doesn't matter which way we start with. x1, or the area of x1, that's the easy one. Okay, that's just going to be that's going to be 100 squared in either case, because that's the actual area of the room that we measured. So that's going to be 100 squared. Now, the area of x2, we either have to take and add 0.6 feet or subtract 0.6 feet. Sorry, 0.5 feet, or add or subtract 0.5 feet from each one. So it's either going to be 100.5 or 99.5, one way or the other. So it doesn't really matter which one we do. So we'll do 100.5 first. That's if we added the tolerance. So it'll be 100.5 squared. So if we do 100.5 squared minus 100 squared, we're going to end up with 100.25 square feet. And then if we do a of x2 minus a of x1, where x2 is now the 99.5 squared. Again, this is still going to be 100 squared. And if we do that one, we should have a negative here. We're going to get negative 99.75. So those are the actual differences in A, or the actual changes in A, and we estimated each one to be 100 plus or minus 100 square feet, which is right in between both of those. So that, I mean, our estimation is, again, it's pretty good. It's only off by 0.25 total in either direction. Not bad. Okay, in part C, if each tile covers 1 square foot and a box of 12 tiles costs $24, how many extra boxes of tiles should Michelle buy for covering the floor, and what would that extra cost be? So let's just think of it this way. If it's exactly 100 by 100, if that is the case, if we have exactly 100 by 100, she would need to have 100 squared and then divide that by 12, and that would tell us how many boxes it would have to have. So I think that comes out to, I'm going to have to plug that in my calculator here. If I do 100 squared and then I divide that by 12, it's going to be about 833.333, 833.333, and so on. So really you need 834 boxes, because otherwise you would be just short. So that would be how many boxes you would need if it was exactly 100 by 100. But because of our measuring error, or our tolerance, we have to see what it would be if we needed to add more boxes. So we have to go with the tolerance that actually added square feet. If we actually subtracted square feet, we'd have enough with the 834 boxes. So we're going to use information from this one right here in order to figure that out. So what we're going to need to do is we're going to need to take the 100.5, because that's what it would be if we had the extra space, and then we'll divide that by 12, and let's see what that's going to give us approximately. Looks like that's going to be 841.67, 841.67, which means that we would have to have 842 boxes to cover it if our error was, if we had an error that actually said, okay, the actual area of this is bigger than what we thought. So we'd have to have 842 boxes. So what really the difference is there, because it's asking us how many extra boxes of tile should we buy? Well, it's 842 minus the 834 that we know that we would have to have for the 100 by 100. So it looks like that's going to be 8 extra boxes, just in case our tolerance was off by the maximum tolerance we had. And then let's see, the boxes cost $24 a piece, it looks like. So we'd have to do 8 times 24. And let's see, what is it? 32, 16, 196? No, 192. $192, I think that's right. So it would be another $192 that we'd have to spend on those 8 extra boxes if our tolerance was off. All right, plenty enough for this video. Kept it under 10 minutes. That should be plenty enough for this section.